Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, audio check, video check. Okay, so here's lesson 11, dilations from different centers. Okay, so we have in this diagram a big house and two small houses, drawing 1, drawing 2, and drawing 3. It says drawing 2 and drawing 3 are both scale drawings of drawing 1. Okay, so A says to determine the scale factor and center for each scale drawing. Okay, so first thing we have to do is determine where this would be, where the center of dilation is. Okay, so it says determine the scale factor and center. All right, so obviously, if I had a center here, for example, O, if this was O, and I scaled this up, drawing 2 would be over here somewhere, and drawing 3 would be over here somewhere. There's no way to get it to be the same drawing. So I'm going to have to move that O somewhere over here so that my rays line up going this direction. And then over here, I can't have the points up here. Or could I? Not possibly, but let's put them down below here. And let me just do something here. My pen whacked, and if I change pages, it fixes it. Okay, so first thing I'm going to do is draw some rays. So I get a ruler and I bring the ruler down and just pick some points on the houses. For example, if I center at this top corner here where the roof meets the side of the house, and I put it here, and I draw a segment or a ray going like so, but I also want to go this way. Okay. So there's one ray. Then if I move to another point, like the top right corner of the door, and draw a ray from the top right corner of this little door here to the top right corner of the larger house's door, and draw a ray like so, then when I do that, that tells me where the center of dilation is. We only need to do 2, but I'll do one more just to show you. And I'll do the bottom corner of the house. So if I line this up like so, it's crossing at the same point. So I'm going to put a dot right here. And then I'm going to erase my lines just because they are, well, no, I'll leave them there for now. Okay, so there's one. So then I'm going to do the same for the other house. And it doesn't matter what points you pick. This time I'll pick the top right corner of the house, and I will draw a ray to the top right corner of this house. And I'll use red for this house, and hitting the top right corner, going through the top right corner like so. It's off a little bit, so if I just rotate this, obviously you can't do this, but delete it and do it again. Accuracy is important here. You're going to miss the point. All right, so let's try this one more time. Top corner, like so. And then I'm going to move, I don't know, the bottom left corner. I'm just trying to use points that I didn't use in the first house, just so they aren't overlapping. And then if I line this up, it was off a little. Rotate it a little bit more, right about there, I would say. Okay, hitting that corner. I'm a little high here, but that's okay. And then I haven't used the window yet, so I'll use the bottom left of the window So if I go to the bottom left of this window and the bottom left of the bigger house's window and draw a ray through it, then I find my point. So I have a point here, I have a point here. Okay, so if I take my ruler now, and we'll notice something here. Well, it's off a little bit. I think this one's off. So let me take a look. Let me delete this. Okay. These points cross right here. So if I bring my ruler up to that point, like so, it's pretty close, but it should be on the same line. So this would be, oh, I don't know. Let's call this O1 and this O2. So drawing 2 and 3 are both scale drawings of 1. Determine the scale factor and center for each scale drawing. So here's the center for drawing 2. So let's call that O2, I guess. And this is drawing 3, so this is the center for drawing 3, so O3. All right, that makes more sense. Okay, so right there. They're off a little bit, but it could be because of my angle not being exact going through these points. Probably that window one. Anyhow, these are on the same line. So it says determine the scale factor and center for each scale drawing. So there's one center, there's the other. Well, what is the scale factor? Well, if we measure the base of this house, it is 1.6, and this is 3.2. So 1.6 times r equals 3.2. To solve for r, we divide both sides by 1.6. Those cancel. And r is 3.2 to 1.6, and that equals, actually it's the other way around. My apologies. Well, actually, that was right. Let me see. 1.6 times r equals 3.2. I had that. Divide by 1.6 on both sides. Cancel, cancel. R equals 3.2 divided by 1.6. And that comes out to be 2. All right. But we're not scaling the little ones up, so that is where I'm going wrong. So that is incorrect because these aren't bigger, they're smaller, and that's how come I was questioning that. So what I should really say is 3.2 times some scale factor equals 1.6. These houses are smaller than the original, so you know that the answer is going to be a fraction, not greater than 1. So when I solve for r, I divide by 3.2. And divide by 3.2. So I'm kind of glad I did that, because that will show you that if you just set it up and leave it and say r equals 2, it doesn't make sense because the houses are not bigger, they're smaller, and it should be a fraction. So setting this up had to be adjusted. It's 3.2 times r equals 1.6. We're going from big to small. And now that comes out to be 1/2. So there's our scale factors. So answering A. The scale factor for each drawing is the same. The scale factor for both is r equals 1/2. Each scale factor has a different center. So if I measure this one, because I didn't yet, that's also 1.6. So drawing 2 and drawing 3 are identical. They're the same size. They're congruent. Okay. And then it says, is there a way to map drawing 2 onto 3 or to map drawing 3 onto 2? Okay, can I map? So if I erase these rays, what they're asking is there a way to map 2 onto 3 or 3 onto 2? So if I drew this line from the top to the top, my center of dilation would be somewhere on this line. But then if I pick the top of the door and go to the top of the door, then you see that they're parallel. So any point that I choose will never intersect. So I can't find a center of dilation. So if I pick this corner here and drew a ray to that corner, continuing it on this way, and the same will be this way, all the lines are parallel. So to answer this question is, since the two drawings are identical, a translation maps either drawing 2 onto drawing 3 or drawing 3 onto drawing 2. Okay, there's a mapping, it would not be a dilation, it'd be a translation. The only way a dilation is going to be the same size as after dilation is when the drawing is sitting right on top of the original. Okay, part C. Generalize the parameters of this example and its result. So the dilation of a figure from two different centers by the same scale factor yields congruent figures that are congruent by translation along a vector that is parallel to the line through the center. Okay, and I had already erased those, but they were right here on this line. Parallel to the line of center. So notice that I drew these lines, these rays for part B, and you can see that all three of these red lines are parallel to the line 02 through 03. Okay. Page 2, exercise 1. The triangle ABC, right here, ABC, this little one, has been dilated with a scale factor of 1/2 from center O and O2. What can you say about the line segments A sub 1, A sub 2, which is right here, B sub 1, B sub 2, and C sub 1, C sub 2. So what they're talking about is three different lines. I'm just going to use my segment tool instead of the ruler just to show you. So B sub 1, B sub 2 is here. A sub 1, A sub 2 is right here. And C sub 1, C sub 2 is right here. So what can we say about the line segments? These three segments, they are parallel. To the line that passes through this. So if I drew a segment now, right here, going through O1, O2, parallel, parallel. They are parallel, okay. And the reason is, the last example, if we went the other way, this was our original drawing, this is scaled up, this is our original drawing, this is scaled up. If we scale the same drawing from two different locations and draw a line through those two centers of dilation, then the two diagrams sides, it will be parallel. Okay. Exploratory challenge 2. If drawing 2 is a scale drawing of drawing 1, this one's drawing 2. Drawing 1's this big gray one, so it's a scale factor of less than 1. R sub 1 is the scale factor and it's a fraction. And drawing 3, this one here, A sub 1, B sub, A sub 3, B sub 3, C sub 3, is a scale drawing of drawing 2. So original drawing is the big one, scaled down to this, and then scaled up to this. of scale factor R2. What is the relationship between drawing 3 and the original drawing? Okay, so A says to determine the scale factor and center for each scale drawing, take measurements as needed. So if I take a ruler, okay, now let's do our initial. So if I take and put my ruler right here at B1 and rotate it so that the ray is going to go through B2, then there's the segment going through. Do the same with C1. Like so. Let me just move this down a little bit. Like so. Still off a little, but that's okay. Very difficult to do with the program. And then finally, like so. So as you can see, I'm off with one of these, and I believe it's the second one. Let me delete that and do it again. Accuracy is really important when you do these. That's better. All right, so there's my point of dilation to go from drawing 1 to drawing 2. It's right here. I don't want to make it that large, just a dot. Okay, so there's O2. Drawing 1 went to here, so that's O sub 2, making drawing 2. Then I have to do the same thing to make drawing 2 scale up to drawing 3. So in doing so, I now line up C2 with C3, or C3, yes, I was right. And that's right here. And then I want to do B2 to B3. And then finally A2 to A3. Okay, so these are way off. They should cross at the same location. So did I do something wrong? Let me take a look. Okay, I redrew those. They're always off a little bit for some reason. So notice A3 goes through A2. This ray comes down. B3 through B2 comes down, and C3 through C2 comes down. And they all meet at relatively the same location now. And that point is, I would say, right here. And I'll call that O3. Okay. This one's out a little. Okay, B2, B1, there we go. So they do all cross right there. There's O3, there's O2. Now if I take my ruler, but I'll just use a segment. Now I'll use my ruler. Take the ruler. And draw a segment. Now I've already used those two colors. Let's use green. And there is my line going through O2. O2 and O3. Okay, so the 2 points of dilation are on the same line. Obviously, any 2 point can create a line. But what's interesting about this is now if I draw rays, and this time I'll use purple, and let's make it thin, yep, purple. Now if I go from B1, because now it says to compare drawing 3 to 1, so if I go from B3 to B1, which is here, and draw a ray through those like so, and draw a ray through C1 through C3, like so, and then A1 through A3, then they all meet at a point, which is right here. Hello, right here. And I don't know, let's call it O4. Okay. So interestingly enough, scaling down drawing 1 to drawing 3 directly gives us a point of dilation that is collinear with the other 2 points of dilation, which is kind of neat. It says to determine the scale factor of each scale drawing by taking measurements as needed. So if I measure, let's just focus on the side BC. So I'm going to say BC, and it's B1C1 equals B2C2 equals, and B3 C3 equals. So I'll measure those 3. Alrighty, so B1C1 is, it looks like about 5. It's a little bit less than 5. Let's go with 4.9 centimeters. B3C3 is right here. And that is 3.7. And B2C2 is 2.3. Okay. Determine the scale factor and center of each scale drawing. So we found the center of each scale drawing here, here, and here. And I guess I should rename those. I don't like the way I named these. Get rid of that, get rid of that, and get rid of that. And I will call this, because it's the first, 1 to 2 is our O1. This is our O2, and this would be our O3. All right, so the original drawing was 4.9, and we scaled it down to drawing 2. So that's B sub 2, B sub 3, C sub 2. So what we would do is take the ratio of 3.7 over 4.9, and that equals 3.7 divided by 4.9 equals 0.755. That's about 3/4. It's an approximation. So I'll just do approximately 3 over 4, 3 to 4. Okay. So drawing A2, B2, C2 is 3/4 the size of the original. Then to find out what the difference between, so let me write that. Let's move these up here. All right, so what were these drawings? These were This was drawing 1 to 2. So this is going from the original drawing to the second drawing. Then I'm going to do drawing 2 to 3. And drawing 2 to 3 would be B sub 3, C sub 3 over B sub 2, C sub 2, which would be 2.3 over 3.7. And if I take my calculator and do 2.3 divided by 3.7, I get 0.62. .62. Maybe that was 2/3, 0.67. Maybe we're just off a little bit. And then I can compare 1 to 3. So if I compare drawing 1 to drawing 3, it would be drawing 3 length over drawing 1's length. Okay. 2.3 divided by 4.9 equals 0.47. So 1 to 2 was a 3/4, or about 0.75. And then 2 to 3 was about 0.62. And then 1 to 3 was about 4.7. Well, this is approximately 2/3. So we have 3/4 and we have 2/3. And 0.47 is close to a half. So just with the drawing and the measurement online or electronically, these are pretty close. So, okay, and looking at this, I noticed I did something wrong. I put the values in the wrong place. B2C2 is the smallest triangle. So I just need to make this 3.7 and this 2.3. I need to switch these. And that will change everything. So I apologize for that. All right, so this is 2.3. And this is 3.7. So now I need to fix all my comparisons over here. So these are all incorrect. All righty. All right, 1 to 2 would be 2.3 drawing 1 to drawing 2 is its smallest one to the biggest one. And that's approximately 2 or a half. I'm off by a little bit. 2.4 and 4.8. So if I added 1/10 to this and subtracted 1/10 from that, that's how much off I am by measuring, by the way. So let's change that to 2.4 and this to 4.8. And then 2 to 3 would be this to this. It's going larger, so you want the 3 on top. So it's 3.7 over 2.4. And again, I'm going to change this to 8. I'm off by 1/10. And then the numbers are more manageable. Okay, so 3.8 divided by 2.4. Is approximately 1.5. So 2 to 1, or 1.58. So that'd be 3 halves. 3 to 2, roughly. And then 1 to 3. Drawing 1 big to small. So that's going to be a fraction less than 1. So you want the smaller number on top, which is 3. So 3.8 is to 4.8, which equals 3.8 divided by 4.8, not 13. 3.8 divided by 4.8 equals, that's close to 0.75, 3/4. Okay, so 1/2, 3/2, and 3/4. Okay, page 3 brings us to part B, and it says, what is the scale factor going from drawing 1 to drawing 3? So we would say that that would be scale factor of R3. And 1 to 3 was right here, and it's 3/4. So R3 equals 3/4. Take measurements as needed. I've already done that. And part C says compare the centers of dilations of drawing 1 to drawing 2 and of drawing 2 to drawing 3. What do you notice about these centers relative to the center of the composition of dilation O3? Okay, so I've already mentioned this. The centers of each for drawing 1 and drawing 2 are collinear with the center of dilation of the composition of dilations, which is dilation 3. So what we're basically saying is O1, O2, and O3 are collinear. Part D, generalize the parameters of this example and its results. All right, so a composition of dilations D sub 01 R1, or O1, I mean, DO1 R1. So what does that mean? Dilation from O1, a scale factor of R1, which was 1/2, is a dilation with a scale factor R1, R2, and a center on O1, O2 line, unless R1, R2 equals 1. If R1, R2 equal 1, then there is no dilation that maps the figure onto the image of the composition of the dilation. Remember, if we dilate by a scale factor of 1, the image does not move. The pre-image and the image are in the same location. There is a translation parallel to the line passing through the centers of the individual dilation that maps the figure onto its image. Okay. Exercise 2. Triangle ABC, which is the biggest one right here, has been dilated with a scale factor of 2/3 from center O sub 1 right here. So 2/3 of it is smaller. It's A prime, B prime, C prime. And then triangle A prime, B prime, C prime is dilated from center O2 with a scale factor of 1/2. So take this and dilate it down 1/2, and here's a triangle half the size of this, halfway between O2 and the original drawing, making A prime, A double prime, B double prime, C double prime. Describe the dilation that maps triangle ABC to triangle A double prime, B double prime, C double prime. Find the center and the scale. So the first thing we do is we draw rays. We do a ray, thin, and I will use red. So we want to go from B through B double prime. Like so. It shifted just a little when I let go. That looks pretty good. Actually, it's got to come down a little here. We want to be as accurate as possible here. All right, B to B double prime, continuing on. All right, C through C double prime. And A through A double prime. Right. That was easy enough. So we found the center of dilation, which would be right here. And it is O3. So we want to know the R now. Well, it's R. First of all, I always like to figure out if R is greater than 1 or between 0 and 1. And obviously going from A, B, C to A double prime, B double prime, C double prime, it is smaller. So R is going to be a value less than 1. It's going to be a fraction. So I'll put my fraction bar here, and we just have to find the scale. Take a ruler, go to the top of the screen and get it. Okay, and two ways we can do this. We can actually measure the rays segments. So from here to here is length 3. Okay, and put this back. From here to C is 9. So the whole thing is 9. So R is 9. To get it down to 3, you'd have to multiply by 1/3. So R is 1/3. So the center of dilation, O3, is right here. R is 1/3. And notice something about the centers of dilation, by the way. They are collinear. How cool is that? O1, O2, and O3 are on the same green line. All righty. Okay, that brings us to the end of lesson 11. Review the lesson summary and go to your problem set.